Interestingly enough, though, if you look at the number of wires going into your house, it's going to be 3 wires. And that's because you actually have dual phase going into your house. And this is for a residential socket that is greater than or equal to 30 amps. So things like, someone tell me what might pull a lot of power in your house, a lot of current, that are in most houses, but that you can't plug into a regular outlet.
Washing machine. No?
Washing machine, probably, you're close. The washing machine probably can go into a regular outlet. It has a motor. It's a fairly big motor, but it can still power it, just like your refrigerator or your freezer. Pretty big compressor motor, but it can still power it. But not your dryer. Your dryer got these heating coils inside that use a huge amount of power. In fact, by the same token, if you've got an electric range, that'll also require a special kind of socket. And those sockets look different. They look like this. And those have a VA, a VB, and a neutral connector. The VA is 120 volts at an angle of 0. The VB is just the phase inverted version of that. And V neutral is still 0. So there's our VA, and this is black still. Here's our VB, and this is white still. I'm sorry. This is the red wire. Your neutral is the one that stays white. And so in every house, now you've got both these wires are hot. So here's your VA. And here's your VB. And here's your V neutral at 0 volts. And they're both 120 volts away from the origin. The only difference is that this is at 180 degrees. Okay, so your leg-to-leg voltage between these two is what? This is your VA leg. This is your VB leg. And so if you were to put a digital multimeter between your black and your red leads, what would you measure? Connor, what do you think? I already asked Aiden.
There would be, is it 0 difference across them?
Well, it's true that it's 120 in one direction and 120 in the other direction. But what's another way of writing 120 at an angle of 180 degrees? That's as a phasor, right? So we could write it as real part, imaginary part. So here's this is what 120 looks like at 0 degrees. Where does 120 degrees, where does 120 get negative at, where does 120 at 180 degrees look like?
It's just flipped across the y-axis.
Just flipped. So what's another way that we could call this? What's another number, a simpler number than saying it's 120 at 180 degrees?
Negative 120.
Yeah, those are exactly the same number. This is the only way we can show it in polar form, though, because for polar form, the first number is always the magnitude. It's always a positive number. It's always the distance away from the origin. But if we wanted to display it in rectangular format, it would be minus 120. It'd be not 120 degrees. It'd be minus 120. All right. So my question is, what is VA minus VB? Or equivalently, what is 120 at an angle of 0 minus 120 at an angle of 180? And Connor, just finishing that up, it is?
240.
240. And you can see that from the phasor diagram that there's 240 volts different. So if you take your digital multimeter and you apply one lead to this upper left section up here and another lead to the upper right section, you'll read 240 volts RMS. Now, something that I think is really interesting is that houses are meant to have balanced loads. The amount of load that's on your VA leg should be about the same as the amount of load that's on your VB leg. And that means that half of your house is divided into two parts. Half of the house is powered by VA and neutral, and the other half is powered by VB and neutral. That means if you go in within a single room, it's always powered by the same leg, by VA or VB, but the different rooms on different sides are probably powered by different legs. That means if you go into a room in your house, look at this outlet in the upper section, single phase power, and if you take a look in a single room at two different outlets, and you connect your digital multimeter between this upper right leg, the V hot leg, on one outlet in the same room to another outlet in the same room, you should get 0 volts difference because they should both be hot. They're both either VA or they're both VB, and no matter which it is, VA minus VA is 0 or VB minus VB is 0. Either way, you get no voltage difference. But if you connect with a long wire, one probe on your digital multimeter to this upper right V hot wire on the left side of your house, and connect the other probe to the V hot on the other side of your house, one side will be VA, one side will be VB, and you'll actually get 240 volts across it. If you take a look downstairs in your circuit breaker, you'll almost always see two columns of circuit breakers. One side will be your VA side, one side will be your VB side. And they'll both be 120 volts relative to your big neutral branch down the middle. Okay, so that's dual phase.